Can you see my screen?
Yes, go for it.
Okay, so hi everyone. My name is Remy Ashiro, and today I'll be presenting my project, Waia Flash Photo Model Stage Mapping. So first, a little bit about me. I'm originally from Japan, and I moved to Hawaii in 2021. And I'm currently, once I came to Hawaii, I entered the Kapiolani Community College. And I graduated Kapiolani Community College as a liberal arts major and transferred to the Chaminade. And I'm currently a data science major at Chaminade University of Honolulu. So why on SCIPE why I joined? I want to build a career in data science, so I joined this project. So this program to strengthen my technical skills and to get hands-on research experience working with real data instead of only classroom examples. And I chose this project because I saw Hawaii's frauded several times this past years alone, and that made me curious about frauding in Hawaii. And I was also inspired by Brian. He's my mentor. I joined his project, which is part of his PhD work. Together, that what I made me want to contribute to fraud research. So, what's the actual problem? There are only limited reports on these fraud in Hawaii, and the gauge reading are confusing. The gauge is like a tool measuring the water height, and the gauge reading are confusing because the number doesn't directly tell you how deep the water is on the ground. And also, frauds here happen barely first in Hawaii, and there are no clear evacuation plan, and most of these communities are located right inside fraud zone. So this photo from the Waialua fraud in March of this year, can you see the line is suddenly raises? This has happened because Hawaii, no, sorry, Hawaii, it happens oftenly. And it helps to compare Hawaii to mainland. Um, the mainland has a larger watershed, simpler topography, much more research, and better system already in place, and many more stream gauges. So Hawaii has a fewer of these resources, which part of why this kind of work is needed here. So here's the data for model. To build the model, we use three main data set. The first one is stream gauge data. This is a stream gauge. I already explained it. This is measuring the water height, and which measure the water height, yeah. And this is the next second thing is the digital elevation model, which give us the topography. And the third one would be land use data, which tells us what's on the ground. So, for example, it'd be like building, forest, or wetland. These maps show the Waihole watershed for each input. And how I did it, we used the GSA SHA Gasha for a model. The model we use is Gasha. It divided the landscape into a grid of cells and uses fluid dynamic physics to stimulate how water moves through them. And we learn it at 10-meter resolution. Gesha is a model that's commonly used in research and engineering study, so it's well established. And this is actually we created the model. Um, so here's how the flow stage model works. We basically feed stream flow into the model until it reaches the specific stream stream gauge height. Yeah. Oh, sorry, Robin. Sorry. Yeah. Okay. So then we connect to each result to active gauge observation, so the mass match real reading. The end result is a fraud map for each gauge height. This picture is an example show the 18-foot scenario. And this is an animation showing the flood map from 12 feet all the way up to 18 feet of gauge height. As the gauge height rises, you can watch the flooded area glows around the map. And now look at the legend on the top left. That's flow depths in feet. Gauge height and flow depth are two different things. The gauge height is the water surface measured at the stream gauge, while the flow depth is how deep standing water actually is at each location on the map. So, sorry. Um, yeah, as the gauge height climbed to 12 to 18 feet, two things happen at once. The flooded area spread wider and the water also gets deeper. So you can see the color shift toward darker blue and purples, which represent deeper water. So a higher gauge reading means more land is underwater, and the water sitting on that land is deeper too. So now what can these map actually be used for? So the first use case is evacuation. We create an evacuation map. Uh, we we define neighborhood in three areas, and the goal is simple: get people safety out before the water reaches to them. This map show the maximum flow scenario, and we divided by red group, yellow group, and blue group. And looking closer at each zone, sorry, the picture a little bit small. For the blue area, um, impact stat at 13 feet, and the loadway is cut off at 15. And for the red area, there are no direct impact, but the entrance from Cam Highway gets cut off at 14 feet. And for the yellow area, um, impacts start at 14 feet as well, and the road is cut off at 17. So this kind of information help us to understand when each community needs to leave, so we can avoid the worst case situation. So that is one example. And this is a second use cases is cesspools. A cesspool is a hole in the ground where a home's wastewater. So when flood water rises and reaches a cesspool, the water mixes with that sewage and became contaminated. So that contaminated water can then spread disease and cause environmental damage across the community. That will be the problem. So that if the fraud happen, water is going to be spread to the community. On this map, um, on this right side map, each bed that represent the cesspools. And what I did was go through each fraud map from 12 feet to 18 feet and manually count how many cesspools were in contact with the flood water at each gauge height. And the graph on the left show the result. As the gauge height rises, the number of cesspool touching flood water goes up. And the more cesspool in contact with the flood water, means more contamination. So this gives us a way to estimate how bad the contamination could get at each fraud level. So through this project, I learned a lot. I improved my Python coding. I learned pandas and matplotlib, and also I got a general understanding on GitHub using DataCamp, like writing a README and pushing and pulling code. And also I learned to work on JStream tool. Actually, I didn't use it JStream tool in this project, but I could learn how to use it. And most importantly, I understand the fraud problem in Hawaii better, especially a lack of information and technology around it. And going forward, I want to keep exploring data science and use it to contribute to society. So this project showed me that data science isn't just about code or number, um, programming statistic, and it can actually help protect people and communities. And that's the kind of work I want to keep doing. And I would say big mahalo to everyone who supported me, my tutor and my teammate. And thank you all for listening. That'll be all my presentation. Thank you.
Thank you very much. Are there any questions? No questions, then